Thank you, Wallace, for the introduction. Ladies and gentlemen, it's a great pleasure to be here today talking to you about my Nuffield Scholarship, kindly sponsored by Micron Biosystems. So, why did I choose to study this topic? Well, in 2014, when I was putting together my application for my Nuffield Scholarship, there was a conference organised jointly by FAO and Wageningen University looking at the subject of insects for food and feed. And so it's not every day that as a poultry nutritionist you get the opportunity to study something so new and innovative in terms of raw materials for your industry. The conference that was organised received a lot of publicity in the trade, not just in the trade press but also in the mainstream media. And although the publications on farming of insects for use in feed go back to the 1950s, the number of papers published on the use of insects in feed has doubled from 800 since 2012. And that has even led to the fact that insects for food and feed now have their own dedicated peer-reviewed journal. Insects are believed to form more than half the dietary intake of the wild turkey and may contribute significantly to the intake of free-range birds. So, are we, as an industry, missing an opportunity to commercialize or utilize insects in a controlled way within a commercial situation? At the outset of my Nuffield, the real interest was looking at insects as an alternative protein source. Protein nutrition is of particular interest to me, as efficient use of protein is particularly important in optimizing performance, cost, and environmental impact. Insect bioconversion offers the opportunity to valorize and bioconvert waste materials into a high-protein feed source for livestock. Particularly, it offers the potential for nitrogen capture and reuse, something that is missing from bioenergy, which is more carbon-focused. In this way, it could help to address pollution through a reduction in nitrogen output and also aid in domestic protein security. So I set out with three objectives: to understand the emerging insect production industry and how and why it is developing around the world, to identify the opportunities for the UK poultry industry to utilize insect products from experiences in other markets, and to identify if insects could be a potential solution for waste materials from the poultry industry. And so the planning started, and what initially seemed like I had set myself an impossible task to track down and interview a small number of researchers and even smaller number of commercial companies operating in this sector, I was soon to find that a Nuffield Scholarship really can open doors. And so I set out on a journey of discovery, spending my time traveling to Spain, Italy, Denmark, Belgium, Holland, France, Germany, Finland, Czech Republic, China, Vietnam, and the USA. And I also had further discussions with people from the UK, Tunisia, Poland, Canada, and South Africa. So how is this insect industry developing? Well, in Europe, I found a high level of interest in insects as a feed protein source. However, the industry here is highly regulated, which is limiting development. Over the last couple of years, there have been many startups looking at insects in feed, and I was fortunate enough to visit three of the largest commercial players operating in insect production in Europe: Insect in France, Protix in Holland, and Hermetia in Germany. Currently, the only open market for processed insect protein is in pet food, and so this is where the focus is currently. The use of insects within aquafeed is expected to be permitted from next year, and this will undoubtedly stimulate growth and development within the industry. In Asia, there was much less regulation, and the industry was still quite embryonic, with little large-scale commercialization. Universities and companies were examining the potential to rear insects on a range of substrate materials, including food waste, municipal waste, and manure. In North America, Canada is leading the way in permitting the use of insect meals in broiler diets since earlier in this year. State by state, the situation differs in the US, with certain states permitting the use of insect meals in animal feed, such as Ohio. I visited diverse examples of where insects were being raised on commercial scale for feed use, and also where insects were being raised on farm for feeding back to their own poultry. So what are the factors to consider in the production of insects? Currently, there are 6 pieces of European regulation controlling or prohibiting the use of insects within feed for livestock entering the food chain. With developments in aquafeed expected next year, progress is being made, and poultry is thought to be next, but it could be in a further 2 to 3 years down the line. The impact of Brexit and how UK legislation will mirror EU legislation going forward on feed materials is currently unknown. Should the EU legislate to allow insect protein in poultry, would the UK do the same without undertaking our own risk assessments? Costs and scale of production are two significant challenges. Insects require aerobic conditions, so a large surface area is required, and these systems are also labour-intensive. One European company that I visited suggested that access to around 30,000 tonnes per year of substrate was required in order to have a viable commercial scale insect production industry facility. The species of interest will be low risk and harvested at the larval stage. Black soldier fly, lesser or greater mealworm, and there's even a group in Scotland looking at the opportunity for kelp fly raised on seaweed. We are unlikely to see species such as housefly or blowfly used in the EU, although they are being used in other parts of the world. In Europe, the most challenging point will be around input materials in order to ensure food safety. Substrates will have to be pre-consumer food waste that is non-meat, vegetable, milk, or egg-based. It is not likely to be high-risk materials such as post-consumer food waste, manure, or abattoir waste. And therein lies a challenge. If that pre-consumer food waste already has a use within the feed chain, are there economic or efficiency gains to be had from bioconverting into insect biomass? For example, it might make little sense to use distillers' dried grains to produce insect biomass when these products could be fed directly into the ruminant or pig markets. So why are these controls on insect production required? Well, in 2015, the European Food Standards Agency issued a report on the potential for insects in feed. And they highlighted in particular that the presence of microbial pathogens and hazardous chemicals in insects are relatively undocumented. And the report recommends further studies on these areas of concern. Without the data to prove otherwise, you have to consider that any contaminant that the insect is exposed to could transfer into the food chain. These risks include viruses, yeasts, fungi, prions, heavy metals, drugs, hormones, pesticides, dioxins, to name but a few. Control strategies will be largely around selection of that substrate and possible further processing, such as sterilization through heat and pressure. On this slide, I'll just show an example of mass balance for an insect production facility. The mass balance will, of course, vary with substrate and the insect that is used. But these figures are based on some data that I received in Asia from a project rearing black soldier fly on post-consumer food waste material. In this facility, 25 tons of food waste was converted to around 6 tons of larvae. When processed, this yielded just over 1 ton of dried, defatted protein meal with a crude protein content of 55%. That had a value in the US of $1,400 in February of this year. That 25 tons of waste also yielded 300 kilograms of fat, which has a value of $950 per ton. That 25 tons of waste also yields around 7 tons of fertilizer, with a nominal value of about £100 per ton. So calculating this out, 1 ton of waste material yields about $90 per ton of value before production costs are taken into account. So where are the opportunities for insects in poultry feed? Although I'd started my journey expecting it to be all about protein, it highlighted some other unexpected aspects for the role of insects within feed. Undoubtedly, insect meals are a source of high-quality protein, but the value of insect protein for fish is much higher than it is for poultry. And that higher value and increased demand from the aquafeed sector could actually price insect protein meals out of the poultry market. Depending on the species, dried insect meal contain around 30 to 40% oil, which is extracted to concentrate the protein. Insect oil is permitted as a feed material within the EU and is already being used by a feed company in Holland in pig and poultry diets. In fact, the oil from some systems may even have an added value. Insect oil from black soldier fly contains lauric acid, a 12-carbon medium-chain fatty acid, which is known to have beneficial modulating effects within the gut flora. The use of live larvae was highlighted as having potential during my visits to Holland, Germany, and Denmark. Live insects may impart an extra nutritional benefit when fed to poultry. These benefits manifest as improved productivity. Birds have been shown to show signs of behavioral modification, being calmer and less aggressive. This is possibly through an enrichment of the environment and permitting the natural foraging behavior of the bird. There are also potential health benefits. These may be from the presence of antimicrobial defensin peptides. These bioactive peptides are thought to form the insect's own defense mechanism against infection. Processing into a processed meal may inactivate the activity of these peptides. More work is ongoing to understand the effect of feeding of live insects. So what were my take-home messages? The potential opportunity for insect products and poultry production extends beyond protein supply. Poultry is not going to be the first target market for insect protein, but opportunities for insect oils and whole larvae and even live larvae may develop. Insect bioconversion allows the opportunistic recovery of nutrients from food-safe, suitable waste streams. Insect production and use faces challenges of cost, scalability, and legislation. And finally, ladies and gentlemen, I would like to extend my thanks to everybody that I met with and spoke with on the course of this study. There is no time to credit everybody, but I am most grateful and humbled for the support, time, and generosity that made researching this scholarship possible and provided an unprecedented global overview of this topic. I would like to thank my past and present employers during the course of the study, Highline International when I started out, and Trow Nutrition GB. My sincere appreciation to everybody within Nuffield Farming Scholarship Trust, fellow scholars, and to Dr. David Parfitt of Micron Biosystems for sponsoring this wonderful opportunity. My grateful thanks to my family for their support and understanding throughout. And lastly, ladies and gentlemen, thank you for your attention.